Hello everyone. Today we're going to discover why plants need energy from light to grow. Just like you need food for energy, plants need something special too. That something special is light from the sun. Look at this picture. Can you see the light patches on the grass? Think of some reasons for these light patches. What clues can you see? Farmers think that tents may have blocked the light during a camping festival. Plants use energy from light to help them make food in their leaves. Have you noticed plants growing toward the light? This process happens in the leaves where plants turn light into the food they need. Without enough light, grass becomes yellow and doesn't grow well. So how can we test if plants really need light to grow? We'll use identical plants in two different pots, one for light, one for no light. We need to think about our variables. What are we changing? What are we measuring? We'll keep one plant in darkness using a box and place the other plant in a sunny spot. We'll observe and measure both plants every day for a week. Design a results table to record what you see. Taking photographs helps us see the changes clearly. Our results will tell us exactly what plants need to grow healthy and strong. The evidence shows us why those grass patches appeared after the festival. We can also test if plants grow toward light using a plant maze. Place seedlings at the bottom and cut a hole at the opposite end. Watch as the plant grows toward the light, just like we predicted. Remember our key idea. Light is essential for the growth of green plants. Plants left in darkness die fairly quickly. Plant shoots grow toward light while roots grow down due to gravity. Now you understand why light is so important for plants to grow and stay healthy. But wait, can plants have too much light? Let's investigate. We'll use pondweed to test if more light helps plants make more food. Pondweed grows in water and uses light energy to make food and oxygen. First, we place the lamp 10 centimeters from the pondweed. Watch carefully. You should see bubbles after 1 to 2 minutes. Count the number of bubbles in 1 minute and record this in your table. Now move the lamp to 20 centimeters away. Wait a few minutes for the pondweed to adjust to its new conditions. Record your bubble count for each distance in your results table. Repeat the experiment, moving the lamp 10 centimeters further each time. Continue until the lamp is 1 meter away from the pondweed. Write up your investigation as a complete scientific report. Plants use sun energy to make food, and they produce oxygen gas as waste. We can see this oxygen as bubbles when plants are underwater. The better plants use sun energy, the more oxygen bubbles they make. Your results will show this amazing pattern. Only 1 to 2% of the sun's energy reaching Earth is used by plants, but this still provides enough energy for almost every food chain on the planet. Scientists always check their results by looking up information from other sources. Remember, plants need just the right amount of light, not too little, not too much. When planning investigations, always think about your variables. Which variables will you keep the same? What are you altering? What exactly are you measuring in your experiment? Great work! You're thinking like real scientists now. Remember to keep your seedlings properly watered throughout the experiment. Check your plants every day and record what you observe. Photographs help document changes you might miss. Soon you'll see amazing differences that prove our hypothesis. Plants don't just need light and water, they also need warmth to grow properly. Plants grow faster in warm conditions than in cold conditions. Look how well these tomato plants grow at 30 degrees Celsius. But what happens to plants when it's too cold? In Iceland, winter temperatures can drop to minus 10 degrees Celsius. But look at these tomatoes growing in heated greenhouses. Icelanders use hot water from deep underground to heat their greenhouses. Looking at our graph, which temperature showed the most plant growth? Let's investigate temperature effects using two identical plants. First, record the height, number of leaves, and flowers of both plants. Place one plant in a light but cool place. Place the other in a light and warm place. Water both plants equally and keep them well watered. Place thermometers next to each plant to monitor temperatures. Observe and measure both plants every day for a week. Record both the plant measurements and the temperatures each day. Some plants are specially adapted to live in very cold places. Taller plants drop their leaves when it gets coldest. Others have thick, waxy coverings to protect their leaves. Many cold weather plants stay small to reduce water loss. Plants in hot places must find ways to save water or get more water. Research 3 ways hot climate plants adapt and share with the class. Some store water in thick, fleshy leaves or stems. Others grow very deep roots to reach underground water. Plants need the right temperature, as well as the right amount of water and light. When plants get all three things just right, they grow strong and healthy. Now you can explain how plants adapt to different environments around the world.